Hello all. In this video we are going to see transportation problem and assignment problem under operations research. In this video the topics which we are going to cover is transportation problem, basic definitions, methods of transportation problem, assignment problem and traveling salesman problem. Transportation problem. Transportation problem is nothing but studying about the transportation of goods from one place to another place with minimum cost. The formation of the transportation problem is given with few elements: AI, which represents the number of supply units, BJ, number of demand units, CIJ, cost of transporting the goods, XIJ, number of units shipped. Here summation AI is equal to summation BJ, which represents sum of supply equal to sum of demand. If this condition satisfied, then the problem is said to be balanced problem. A problem is solved only if the problem is of balanced type. If it is unbalanced, we need to make the problem balanced before solving the problem. Also, we should check for the rim condition m plus n minus 1, where m represents number of rows and n represents number of columns. If the number of allocation is satisfying the rim condition m plus n minus 1, then the problem is degenerate problem. Otherwise it will be non-degenerate. The basic definitions which we are going to see under this transportation problem is feasible solution. Feasible solution means the set of non-negative allocations coming under the solution set. Basic feasible solution which satisfies the rim condition m plus n minus 1 with non-negative allocations. Optimal solution which minimizes the transportation cost. The methods for solving this transportation problem is otherwise called as method for solving IBFS. IBFS means initial basic feasible solution, or northwest corner rule, least cost method, Vogel's approximation method and Modi method. Least cost method is otherwise called as matrix minimum method. Modi is abbreviated as modified distribution method. In this presentation, we are going to see only the northwest corner rule and least cost method. First comes the northwest corner rule. This algorithm is given here, where we can see this using the problem, so it will be easy to memorize the algorithm. Given here is a problem where A, B, C represents the number of plants and distribution centers are D, E, F and G. Supply and demand is given here. We need to check whether the given problem is balanced problem or unbalanced problem by adding the supply values and requirement values. Supply values are 6, 1 and 10. If we add this, we are getting the value as 17. Requirement values are 7, 5, 3 and 2. If we add this 7, 5, 3 and 2, you will get the value 17, which means sum of supply is equal to sum of requirement, where this problem is a balanced problem. So we can start solving this problem by using the northwest corner rule. So among this given matrix, the northwest corner box is A, D, where the number 2 is placed. So we need to start allocation in the place of 2. What value we can allocate it there? Minimum of supply and requirement. So minimum of 6, 7 is 6. So we are allocating the value 6 there. Once if the value is allocated, it should be subtracted from the supply also with the requirement. So if I subtract the 6 from supply, it will become 0 in the place of supply and 1 in the place of requirement. So now if supply is 0, we need to cross off that row completely. If requirement is 0, we need to cross off the column completely. In this problem, supply becomes 0, so we are crossing off the first row completely. Now the northwest corner box is B, D, that is the place of 1. What value can be allocated there? Minimum of supply and requirement. So minimum of 1, 1. So both the values are 1, so we can allocate 1 there. We need to subtract that allocated value among supply and requirement. If we subtract it, supply is becoming 0, also requirement also 0. Now we need to cross off the corresponding row and column. Now the northwest corner box is C, E. So there we need to allocate the minimum of supply and requirement. Minimum of supply is 10, 5, where 5 is the minimum value. We can allocate that 5 there. We need to subtract the allocated value from supply and requirement. If we subtract it, supply will become 5 and requirement will become 0. Cross off the value where we got 0. So the remaining two rows are there, which is CF and CG, where CF is the northwest corner box. We need to allocate there in the same procedure what we have done so far. Continue till all the allocations has been done. Now count for the number of allocations. So the number of allocations is 5 allocations. Check for the rim condition. Rim condition is m plus n minus 1. M represents number of rows and n represents number of columns. So m here is 3 rows and n is 4 columns. So m plus n, 4 plus 3 is 7, 7 minus 1 is 6. We need to have 6 allocations, but we have only 5 allocations. So what we need to do? We need to introduce a small value epsilon in any place of the given matrix, where that epsilon value tends to 0. After making it all the allocations satisfied, we need to calculate the transportation cost by multiplying the allocated value with the cost in the corresponding box, so that you will get the transportation cost. For this problem, the transportation cost is 116. Next comes the unbalanced transportation problem. That is, if sum of supply is not equal to sum of demand. Here is an example. In this problem, sum of supply is not equal to sum of demand, where demand we are lagging with 20 values. So we need to introduce a dummy column where we have lagging. If sum of supply is less than sum of demand, we need to introduce dummy row. So wherever it is necessary, we can introduce a dummy row or column. So after making the problem balanced, we can start the procedure of northwest corner rule as we have seen so far, and we can calculate the transportation cost. Next comes the least cost method. Here is an algorithm. Let us see a problem to understand an algorithm better. So given is a problem, we need to check whether the problem is balanced or unbalanced first. So given here the problem is a balanced problem. So directly we can go to the method. As the name says, least cost method, we need to find the least cost among the given matrix. Here the least cost is 1. Since we have 2 ones, we can allocate in any place. If we have only 1, then we can choose that place as the allocation place. But here we have 2 ones, so we can choose any one's place. Let me choose this place where E and C intersects. So I am going to allocate a value there. What value can we allocate? Minimum of supply and demand. Minimum of supply and demand is minimum of 8, 18, where 8 is the minimum value. So I am allocating the value 8 in the place of 1. I need to subtract the allocated value in supply and demand, so that supply is becoming 0 and demand is becoming 10. Next again I am going to see for the minimum element. So already we have 1 as a minimum element remaining. I can allocate 1 in the place of 1. Minimum of supply and demand. Minimum of supply and demand is minimum of 7, 14. So 7 is the minimum element where I can allocate it. After allocating it, I have to subtract that allocated value from supply and demand. This process will be continued until all the allocations got satisfied. That is, all the supply and demand should get satisfied. After this, we need to check for the rim condition. Here the rim condition is m plus n minus 1. M represents number of rows, which is 4, and n represents number of column, which is 3. So 4 plus 3 minus 1 is 6. We have 6 allocations here, so the rim condition is satisfied. So we can calculate the transportation cost by multiplying the allocation value, also the corresponding values, corresponding cost in the box. So here 7 into 2, 4 into 3, 1 into 8, 4 into 7, 1 into 7 and 2 into 7. Add all the multiplied values so that you will get the transportation cost. So this is how we can find least cost method. Next comes an assignment problem. Assignment problem is nothing but assigning a job to a person. But we should ensure that a person is assigned with one job. He is not assigned with many jobs at a time. This should be the rule. So process for solving this assignment problem is found by a person called Hungarian. So he is given a matrix like this, where this Cij represents C11, C12, C13 represents cost of allocating a job to a person. So we need to minimize the cost of allocation. That is what the aim of this assignment problem is. Hungarian is a person who finds this assignment method. He is given as an algorithm. This algorithm will be betterment of understanding if we see through a problem. Let me give a problem where 4 persons and 4 jobs is given here. We should ensure that the problem given here is a square matrix. That is, number of rows and number of columns should be equal. If it is not equal, then the problem is unbalanced. So in that case, you need to introduce a dummy row or dummy column where all the elements of the dummy row and dummy column should be 0 in order to make the given matrix as a square matrix. So obviously, given here is a square matrix, so we no need to introduce a dummy row or column. We can proceed the assignment process. So now first step is to make row reduction. How to make this row reduction? Find a minimum element in the first row. Subtract that minimum element throughout the first row. Now find minimum element in the second row. Subtract throughout with that element. Again in the third row find the minimum element. Fourth row minimum element. Likewise, we should find minimum element in each and every row and we need to subtract it with all the corresponding rows. That matrix is called row reduction matrix. Now this matrix is going to consider for further calculations. Now the second step is to find column reduction. Column reduction is finding minimum element in each and every column and subtracting with the same element in the corresponding columns. So for the first column here, we have 0 as the minimum element. So it is not going to affect. The second column 2 is the minimum element. So we are going to subtract the element 2 with all the elements in the second column. Coming to the third column, here also the minimum element is 2. So we can subtract 2 throughout that column. Fourth column 0. So it is not going to affect. Now this matrix is called column reduction matrix. This column reduction matrix is going to consider for further calculation. Now we can start the assigning process. Here assignment means marking in the form of rectangle box. So this marking has to be done only for the 0 element, not for any other numbers. So this assignment to be done for one row, one column only once. So each and every row and column should have only one assignment. So let me make an assignment like this. So I have made assignment for the first row second element. Corresponding zeros in that row and column to be crossed off. Cross off is crossing off the zeros. Only the 0 elements. Coming to the second row, I am marking assigning for the third column. Corresponding zeros in that column and row will be crossed off. Third row D column and fourth row A column will be assigned. This boxes represents the assignment. After assigning it, I need to calculate the transportation cost, assignment cost by adding the corresponding elements in the question matrix and we need to add it. So this is the assignment process. Next comes the traveling salesman problem. Traveling salesman problem is more or less equal to the assignment problem. But what is different in this case? The different thing is we need to visit each city only once. Also we should return back to the same city where we have started. This is the condition. How can we identify a difference between assignment problem and traveling salesman problem? So in the traveling salesman problem, the leading principal diagonal will be given with any variables or infinity symbol or hyphen. Given here an algorithm to solve the traveling salesman problem. So if we see a problem to make the algorithm understand properly, I have given a problem with traveling salesman to visit 5 cities A, B, C, D and E. I need to visit all the cities and I have to come back to the same city where I have started. So what should be the sequence of visiting all the cities and what will be the cost of visiting the cities? That is what I am going to calculate it now. So if I proceed with an assignment process, I am getting an assignments like this, where I am starting from city A and visiting city E. Now I am in city E. So from starting E, again I am visiting A, which means from A I am going to E and from E I am coming to A again, where I didn't visit the cities B, C and D. So this is not the complete procedure for traveling salesman, but for assignment it is complete. In order to make the traveling salesman condition satisfied, I need to make the proper sequence of visiting all the cities. So case 1, what I am going to do is, I am going to choose another minimum value which is 1 in the first row and I am going to assign for that row. After doing the assignment in such a way, I am getting a sequence that from A I am visiting B, from B to C, C to D, D to E and E to A, which means I am visiting all the cities. Also, where I have started, I came back to that city itself. So this condition is satisfying the traveling salesman. So now we can calculate the traveling cost by adding the corresponding elements in the given question, so that I am getting the cost of traveling is 15,000. Case 2, you can choose second minimum element which is in the third row, fourth column. But this will not give you the proper sequence where the city C is visited twice. So this case will not satisfy the traveling salesman. So we can choose case 1 as a solution. Let me see another kind of a problem where we are not getting the assignment directly like the previous problem. We need to make some procedure. So that problem I have given here. Row reduction, column reduction in the same assignment procedure. After that, making an assignments. So while making an assignment, from work 1 the job 4 is assigned. Again from 4 1 is assigned. So 2 and 3 is not yet visited. I am going to make the assignment little bit change by making this 2 element as the assignment. Again I am not getting the proper assignment. So what I am going to do is, I am going for the other procedure that here one row is not with an assigned value. So that row I am marking. In the marked row, I have one 0 with cross off. So I can mark that column. In the marked column, I have one assignment. So I am marking that row. Again in the marked row, I have one 0. So I am crossing off that. But in the marked column, I don't have any zeros further. So I am leaving this marking process here itself. Now, unmarked rows and marked columns. Here marked and unmarked means where I have made a tick mark. Unmarked rows and marked columns are crossed off, striked off. Now, we are going to see for the undisturbed elements. Undisturbed in the elements in the sense where this crossing off has not been done. And in that, I have to find minimum element. That minimum element is to be subtracted with that undisturbed elements. And it should be added in the place of intersecting the crossing off. That cross of unmarked and marked row, no, that value I need to add it. That we should not disturb the symbols. By doing that, I am getting a new matrix as the matrix which I have given below. Now I am going to start my assigning process. So in this assigning process, I am getting a sequence as 1 to 2, 2 to 3, 3 to 4 and 4 to 1, which satisfies the traveling salesman condition. So I can find the transportation cost here easily. So this is how we can use the traveling salesman. So yeah, as a nutshell, what all the things we have seen in this topic is transportation and assignment problem, methods for solving transportation problem, and for methods for solving assignment problems we have seen. Thank you.